Multiplying matrices by hand is how we are able to achieve our level 3 and our level 4 in our standard for matrices. So to multiply matrices, there's something that you must understand about the actual dimensions of the matrix. You can only multiply two matrices if the number of columns in the first matrix is equal to the number of rows in the second matrix. In other words, when you write the dimensions next to each other, the middle numbers must match. Here's an example of how you would multiply matrices. This is here for a reference, but this is not honestly what I use to teach it because it can get very confusing. But the idea is that you take the rows in the first one and multiply it by each of the columns in the second one, and that's what makes up the answer matrix. Now, if you look at this matrix, though, you can use it to decide whether or not it can be multiplied. This is a 2 by 2 matrix, meaning it has 2 rows and 2 columns, and so is this one. And if I look at the middle numbers of this matrix, I can see that they are both 2's, which means I'm able to multiply this. Now, the interesting thing, too, is that the outside numbers actually tell us something as well. The outside numbers tell us what the dimensions of the answer will be. So the answer will be a 2 by 2 matrix as well. Let's take a look at another example. You might want to write this down. So we have a matrix with dimensions of 3 by 2 and another matrix with dimensions of 2 by 4. And I want to multiply matrix A times matrix B. In order to tell whether or not I can multiply it, I must look at the middle dimensions. And since they match, that means I can multiply them. And the answer matrix, or the product matrix, would be a 3 by 4 matrix. Now let's jump into how we actually multiply matrices. I suggest that you get some highlighters because I think that it helps you kind of visualize what numbers came from where. So if you need to pause the video to get some highlighters, that would be a great plan. So on this first example, I'm just going to make a little correction here. We don't need the E in front. On this first example, we have to write our dimensions to make sure that I can multiply them. So I have a 2 by 2 matrix and a 2 by 2 matrix. Since those middles match, 2 and 2, it means I can multiply. And my answer matrix will be a 2 by 2 matrix. Let's go ahead and do that for all of the examples before we get started in actually multiplying the matrices. This one, 2 rows, 1 column, so it's a 2 by 1 matrix. And the next matrix is 1 row and 3 columns. Since the middle numbers match, I can multiply these two matrices, and the answer matrix will be a 2 by 3 matrix. Let's take a look at the bottom two. This is a 2 row and 3 column matrix. If you struggle with remembering which one is a row and which one is a column, I always like to think of the columns as being up and down, just like the columns on a building. Next one, this is 2 rows, 2 columns. The middles of these two matrices, the dimensions of these two matrices, don't match. Therefore, we are unable to multiply these. Our answer would just be that it's not possible. Let's take a look at the last example. This is a 2 row and a 4 column matrix. This is a 4-row and 2-column matrix. Since those middles match, we're able to multiply, and the answer matrix will have dimensions of 2 by 2. Okay, so we've determined which of the examples are able to be multiplied. Now it's time to actually work through the matrix multiplication. Now, the standard requests that you do this by hand, so therefore there has to be a significant amount of work shown to show that you understand the process by hand. The standard, however, does not say that you can't check your answers with your calculator, and I highly suggest that you check all of your answers with your calculator. There's so many little places to make a computational error that it's really in your best interest to, when you're finished, check your answer, make sure that you didn't make a mistake along the way. All right, here's how we're going to use our highlighters. So, like I said before, we are taking the rows and we are multiplying by the columns. So if I take the first row and I multiply it by the first column, then my answer will actually end up in the 2 by 2 matrix in the first row, first column. So let's go ahead and see what that looks like. So we are going to multiply 2 times negative 6. And then we will add the 1 times the negative 2. This is exactly the formula that shows a 2 by 2. But the reason why I don't use this to teach, other than it being a little confusing for some students, is that it's not applicable when we move on past the 2 by 2 matrix. You really have to kind of get a feel for what's happening. We're taking this row, we're multiplying it by this column, and it happens with the corresponding elements, and then we add those two together. Okay, so that number, or that answer, will make up the first element in the first row, first column. To get the next one, we'll need to take the first row and multiply it by the second column. So our answer will be in the first row, second column. And we'll take 2 times 3 plus 1 times negative 4. Next, we will move down to the next row because we've now exhausted this first row to all of the columns. So the next row will be the second row times the first column again. And it will go in the second row, first column. So 7 times negative 6, that would be the first element in each, plus negative 5 times negative 2. And yes, if you wanted to just go ahead and write this as a negative 5 or minus 5, that's fine with me. And then our last element will be made up by the second row times the second column. And that answer will go in the second row, second column. 7 times 3 and negative 5 times negative 4. As you can see, we have kind of created our 2 by 2 answer matrix, which is what we said that the answer matrix would have for the dimensions. The next part is just computation. 2 times negative 6 gives me negative 12, plus 2 times negative 1 gives me negative 2. 3 times 2 gives me 6. 1 times negative 4 is negative 4. 7 times negative 6 is negative 42. Negative 5 times negative 2 is positive 10. Then 7 times 3 is 21. Negative 5 times negative 4 gives me positive 20. And then we'll just add. Negative 12 minus 2 gives me negative 14. 6 minus 4 gives me 2. Negative 42 plus 10 gives me negative 32. And 21 plus 20 gives me 41. Now I'm not going to show you how to get these on your calculator for all of the examples, but I will walk you through on the first one. So we need to enter our matrix into our calculator. So remember, we press second and matrix, and then we go over to edit. And we are entering in our first matrix, which is a 2 by 2 matrix. 2, 1, 7, negative 5. Second matrix, go over to edit, and we'll enter in matrix B, which is also a 2 by 2 matrix. Negative 6, 3, negative 2, negative 4. Second, quit. Now it's time to take matrix A times matrix B. Matrix A times matrix B. And we have negative 14, 2, negative 32, 41. And the work to back it up. This is where the majority of the standard is really rooted. The answer is nice, but the standard is asking about the process. Let's move on to the second one. We'll take the first row and multiply it by the first column, and we'll put our answer in the first row, first column. Then we'll take the first row, we'll multiply it by the second column, and we'll put our answer in the first row, second column. Then we'll take our answer, or our first row, and we've still got one more column to go, and we'll put our answer in the first row, third column. Now for the next row. Second row, first column, goes in the second row, first column. Second row, second column, goes in the second row, second column. And finally, the last row, last column, goes in the last row, last column. So now you can just look at the colors to decide what goes where. I'm showing you kind of 3 different ways to walk through this process. Whichever order of the steps you like to do is perfectly fine, but I am going to show you kind of 3 different orders to do the same exact steps. So we're going to look at the orange one first. Negative 9 times negative 1. Then we'll look at the pink one. Negative 9 times negative 10. Then we'll look at the yellow one. Negative 9 times 1. And move to the next row and look at the green. 6 times negative 1. Blue, 6 times negative 10. And then purple, 6 times 1. It's time for us to do our multiplying. There's no adding here because there was only one row times one number in each of the columns. So we have negative 9 times negative 1 is 9. Negative 9 and negative 10 is 90. Negative 9 and 1 is negative 9. 6 and negative 1 is negative 6. 6 and negative 10 is negative 60. And finally, 6 and 1 is 6. And of course, don't forget, we do need brackets to make it an actual matrix. All right, our last one. So the last way to set this up, some people really struggle with when I'm saying it goes in the first row, first column, second row, second column, that kind of a thing. So I encourage those students to take a look at the 2x2 matrix that you said your answer will be. And kind of draw yourself a grid. 2 rows, 2 columns. So that then you can kind of see where they're going to end up. We'll take our first row, multiply it by the first column, first row, first column, or the first spot, if you will. And doing this way, it actually moves in the same way that your calculator does when you're entering in your elements for your matrix. First row, second column, first row, second column. Second row, first column, second row, first column. And then finally, second row, second column, and there's only one blank left. It's got to be the second row, second column. This time we'll have a lot to multiply. 2 times 6 plus 5 times negative 7 plus 3 times 2, and finally plus negative 1 times negative 1. And of course, the one time I write the plus is really what we want to do, minus 1 times negative 1. For the pink, we have 2 times negative 3 plus 5 times 1 plus 3 times 0 plus negative 1 times 0. Then we'll follow the yellow. Negative 3 times 6, 1 times negative 7, plus 8 times 2, plus negative 3 times negative 1. Then last one, following the green. Negative 3 times negative 3. 1 times 1. 8 times 0. Plus negative 3 times 0. And it's time to simplify. 2 times 6 gives me 12. 5 times negative 7, negative 35. 2 times 3 is 6. Negative 1 times negative 1 is positive 1. 2 times negative 3 is negative 6. 5 times 1 is 5. And then 3 times 0 and negative 1 times 0 are both 0. So I'll just put them in there to hold the spot so we can see that there's 4 numbers in all of them. Negative 3 times 6, negative 18. Negative 1 times negative 7, negative 7. 8 times 2 is 16. And negative 3 times negative 1, positive 3. Negative 3 times negative 3 gives me 9. 1 times 1 is 1. And of course, multiplying by the zeros, they're just 0. Our brackets are what make them matrices. And our final answer would be 12 plus negative 35 plus 6 plus 1 is negative 16. Negative 6 plus 5 is negative 1. Negative 18 minus 7 plus 16 plus 3, negative 6. And then finally, 9 plus 1 is 10. And like I said before, I really encourage you to always check your answers with your calculators because it's so easy to make simple computation errors, and I'd hate for that to impact what you're able to show me in your understanding.